The following lesson covers Chapter 9, Hydrograph Analysis. The following series of video and face-to-face lessons will cover the following learning objectives regarding hydrograph analysis. How is a hydrograph interpreted? We need to identify the different components within a hydrograph. Next, base flow is water that is in a channel or stream regardless of precipitation. In design, we need to be able to identify base flow. Thus, how to perform base flow separation is essential to eventually determining total runoff. Third, when it rains, runoff does not always begin immediately. Thus, evaluating and calculating excess precipitation from a rainfall hydrograph is an essential step in hydrograph analysis. Fourth, unit hydrographs are essential components of developing design direct runoff. Thus, we will need to cover how to define and determine and develop a unit hydrograph. And finally, once excess precipitation and the unit hydrograph are determined, we need to be able to calculate the direct runoff hydrograph. An introduction. By definition, a hydrograph shows runoff as a function of time. It is a plot or graph which displays the variation of discharge with respect to time, as shown in this schematic. First, a hydrograph is an essential tool to evaluate peak discharge for a location. The peak discharge will provide sizing requirements for channels, culverts, bridges, the low chord of a bridge, etc. The only way to perform flow or flood routing is through hydrographs. Routing flows through a watershed is essential, and hydrograph analysis can be used to do this. As the size of a watershed increases, the rational method will overpredict the design flows due to its inability to accurately account for storage. Thus, hydrograph analysis is essential for large watersheds. Finally, it is used to determine the time distribution of runoff when stream gauge information is either unavailable or inadequate to justify statistical interpretation. Thus, hydrograph analysis is used in design conditions when real data is unavailable. So, if we had real data and we wanted to find it, where can we determine it? Available data in the United States can be obtained from the waterdata.usgs.gov website, as shown in this screen capture. In the upper right-hand corner, it'll ask you for a geographic area. This geographic area is broken up by states. Next, you can click on the Current Conditions tab. This will take you to the region stream flow data. There are tables which contain all streams data that you can select. Once you pick a location and a time, you will be able to then view a hydrograph. This hydrograph shows the Santa Ana River near Mentone, and it shows you that for the most part there's very little flow. On occasion, you will see a peak in the hydrograph, and this can be associated with rainfall events that happened around those times. If you look back at the rainfall data that occurred in September, early October, and late October, you will notice this coincides with actual rainfall events. So let's look at a total runoff hydrograph and make sure we understand how to evaluate it. So by definition, a total runoff hydrograph is composed of both direct runoff for a specific storm plus base flow. So let's discuss how to read the hydrograph. A hyetograph is shown to represent time as a function of rainfall intensity. This is all the rainfall that falls for a given storm event. However, it should be noted that some rainfall does not necessarily generate direct runoff, and we will discuss this more in detail in our excess precipitation lesson. The following depicts an actual hydrograph. The initial flow of the initial few minutes of the hydrograph shows that the flows are decreasing even though rainfall is falling. This is occurring because the initial rain is abstracted and flows are infiltrating or being absorbed by the environment. This rainfall is considered initial abstraction. Thus, the time from the origin of the hydrograph to the lowest point is considered the time of initial abstractions. Next, the time from the lowest point across the hydrograph as a straight line is referred to the base time. All flows below this point are considered your base flows. Next, the time when runoff begins to the highest point on the hydrograph is referred to as the time to peak. Finally, the lag time is the time from the center of the mass of the excess rainfall to the peak. It explains the delay of water moving within a system. It can be calculated as follows. The lag time is 0.6 times the time of concentration. There are many other equations available for lag time. This is just one. Highlighted in red refers to the rising limb. It is the increase in discharge as water moves through the watershed. It responds to the rain event. The following limb or recession represents the end of the storm and the flow or water moving out of storage. The inflection point is the point located on the hydrograph where we start getting groundwater interactions back into the stream. This provided a summary of hydrographs.